Good morning, good afternoon, and welcome to our global audience, to all of you, to today's webinar, UVC Coil Cleaning for Healthy Buildings, the first in a new three-part series. My name is Will Gerard, UVDI's Director of Global Marketing and Product Strategy, and I have the pleasure of introducing today's webinar. Today's program will review the fundamentals of UVC coil cleaning by both sharing some basic concepts and common questions, and more importantly, hearing and addressing your questions in real time about this impactful technology. Before I get started, I'd like to share a few webinar logistics. Today's program will be recorded so that all of your questions are captured, and it will be available for on-demand viewing later this week. During the presentation, to avoid technical challenges, you will automatically be muted and your cameras will remain off. Most importantly, to share your questions, please do so using the question box, which is located on the right side of your screen. For any technical issues, please type those into the questions box as well, and we'll address those to get them resolved. And now, without further ado, to get started, I'd like to turn it over to our moderators for today's panel, starting with David Heidel. Dave, you are muted.
I had a little audio difficulty. We okay now?
You're good now, buddy.
All right, great. All right, well, let me start that over. Will, thanks. Appreciate it. On behalf of UVDI AirSide team, I'd like to welcome everybody from across the globe. Looks like we have people that are in the morning, afternoon, and evening time. To get us started here, I want to make sure that our question function is operational. So if you can go into the question box and type in your first name, state of provenance, and the country that you are joining us from. We'd like to make sure that that function is working because it's going to be open throughout the presentation and allow you to type your questions in. And we have Ed, Maryland, Brandon, USA, Georgia, Kalamazoo, North Carolina, South Carolina, Florida, Texas, Oklahoma. All right, so it looks like the question function is working just perfectly. Appreciate that. Well, the real core of today's presentation is going to be furthering your knowledge about the use of UVC for coil cleaning. And I can't think of anybody else to cover that in a more in-depth way than our VP of Technology and Innovation, Dr. Ashish Mathur, and I'm going to turn it over to him now.
Thanks, Dave. Can you guys hear me okay? Can you guys hear me okay?
Yes.
Okay. Hello, everyone. My name is Ashish Mathur. I am Vice President of Innovation and Technology at UVDI. I've been here for over 15 years. Regarding my UV experience, I've been doing UV research development engineering at UVDI for that time period. I'm also currently chair of the UV technical committee at ASHRAE, where we are responsible for everything related to UV technology. So it's handbook chapters, standards, guidelines, research projects, programs, seminars, and everything related to that. I'm also on the board of the International Ultraviolet Association, where there is an industry group which I'm actively participating. Again, everything related to UV applications. So hopefully this webinar would be informative to you, and hopefully we'll have a healthy Q&A session right after my short 30-35 minute presentation. So as I get started, go over the learning objectives. Basically look at how UV technology used for coil cleaning and disinfection. We'll review some of the common questions we've been asked over the years related to the efficacy. How does it work? How do you apply it? What are the current guidelines from the industry by ASHRAE? What is the peer-reviewed literature saying about UV? And then, of course, the most important thing is get to your questions, anything you wanted to ask related to this topic. So as we get started, I want to first initiate a brief poll to learn about you and your experience with UVC for coil cleaning. So the question is, do you currently use or specify UV for coil cleaning? Your options are, yes, it's installed in my facility. Whether you specify UV. Number 3, we don't use or specify, but interested in just learning about it. Or D, I'm not sure. So, and Dave, I'm going to hand it over to you to run that poll.
All right, thanks, Ashish. We're going to launch that right now. Everyone should see the poll up on their screen, and if you can select the correct choice for you, and we'll give you about 10 or 15 seconds, and then we're going to share the results with the group. Okay, great. Looks like we've got quite a few responses. I'll let you think in your own mind what might be the top response, and I'm going to close out here, and we will share the results here in a minute. Okay, here's our results. We can see there are some that have it installed in the facility. That's great to see. We can see that there's a number of companies that we have on with us today that are in the specifying world of the HVAC equipment, and it looks like you do specify it. It looks like we do have a number that are not currently using it and are interested in learning more about it. And that's really what the core of our presentation is to give you that information and find out what questions you have. And that's what Ashish is going to be doing throughout his presentation. We have a few that's not sure, and at the end of this, we're hoping we're able to fill your your need for understandings of what the real value of UVC can provide for coil cleaning. With that, Ashish, I'm going to close out the poll and turn it back over to you.
Right. Thanks, Dave. So it's really interesting that we have a wide variety of audience, and it'll be interesting to get questions from people who are actually using it today and specifying to really get their input and feedback or questions related to what is it you're seeing and what are the challenges you're facing related to that question, and what are the questions which typically come up from your end users and your customers too. So, sorry, I'm starting off with some really dirty pictures, but this is what it is. Coils can get really fouled and they can get really dirty. What you can see here is a dirty coil. It's not just rusted, but you can see the bottom left slide is showing a lot of debris and organic stuff built up. And what is that stuff? Where is all that stuff coming from? How is it growing on the coil? I think we need to understand that. Of course, we have contaminated air outside. We have air being recirculated inside the building, coming back to the coil. Maybe you don't have great filters, or even if you have filters, when you change them out, you've left an opening and you're basically allowing stuff to come in. And then, of course, the cooling coil itself and the water is a perfect breeding ground. So there are several conditions which can result in bacteria, mold, and fungi growing on a coil in the form of biofilms, not just on the surface of the coil, but also depending on the depth of the coil, it can be penetrating into the fins and grow throughout the depth of the coil. So of course, mold spores are found in nearly every environment and brought into the building through door openings and outdoor air supplies. So even if you have a high efficiency filter, a filter replacement can cause a momentary breach and allow these not just spores, but also the organic matter and dust and particles which can go bypass the filter and then get deposited on the coil. And the coil now starts acting as a filter, but then it's a breeding ground for all these microorganisms to grow on it. Of course, the water and the temperature conditions on the coil are a perfect perfect, ideally suited for that as well. So as we go through what's really growing in the coil, there are several studies which have delineated what are the typical microbes which are identified, not just from the coil, but throughout the HVAC system. What I'm highlighting here is on the left-hand side, which is bacteria and fungi. I'm not going to read out all the names, but it's a pretty big list. The most common ones, which we've heard of, and when you do some testing, you will see Pseudomonas aeruginosa, you would see staph, and of course, Legionella has been a problem. It's coming from the cooling tower through the water supply. The Cladosporium has been identified. Aspergillus has been identified. Stachybotrys has been identified as well. The viruses we'll talk about in the next webinar topic, where we talk about airstream. So you've heard about the recent outbreaks of the Legionnaires disease, which have been associated with the airborne transmission of Legionella, and they're coming from cooling towers, and then they get deposited on the coil. So so the first thing is, how do you know that your coil is fouled? What's a quick way of testing it? And this is something which we've done over the years and help people identify how badly your coil is fouled. So a typical and the most common way is you take a dry sterile swab. We've all used swabs for, unfortunately, for COVID testing, so you're familiar with that. But then there are some other options too. You have sponge swabs, you have Rodak plates as well, which you can use. If you want to see how your UV system worked or how your cleaning, whatever cleaning you're doing today has worked, you can do a swabbing before your treatment and then after the treatment and see if it made a difference. And you don't just want to do one spot. You want to get the whole coil area, upstream, downstream. Also, you want to go inside the fins and get some samples from there. You'll be surprised. The thing is, these biofilms and microbes are so small, you can't see it with your visible naked eye. That's why you have to take the swab, send it to a microbiology lab, and do that culture testing. There is no real-time biological indicator, unfortunately. So you have to grow it, you have to do a culture and send it to a lab. And don't forget the drain pan. The drain pan is also a breeding ground for all of this. So the kind of information you can get back from your testing is just a total colony count, which is, okay, what is my CFUs? Or you can actually get into the detail and say, okay, is it bacteria, is it mold? And what is that species of bacteria or mold which has been growing? So this is the main issue, the biofilms. The moist and dark environment is a perfect breeding ground for the formation and growth of biofilms on the surface and on the inside of the coils. They can start forming when a group of microbes sense a given surface and they start sticking to it. Then they start to form colonies and create a sticky extracellular matrix which protects the embedded microorganisms inside, and it becomes kind of a source of nutrition to all these microorganisms which are growing inside the biofilm. And then you have to protect it, and then it's protecting it from any traditional biocides or steam or chemical cleaning which has been used. The other thing you need to notice is that the biofilms are really more insulating than a standard aluminum or your coil material, and they're 1,000 times more insulating. That means the heat transfer capability of biofilms is very poor compared to aluminum. So there's a direct impact on heat transfer. The table on the right is basically showing that the loss of heat transfer as the thickness of your biofilm or your scaling increases. So it's a question of time that these biofilms keep growing and start affecting your energy. So the energy impact from a foul coil is pretty significant, and it affects the whole system. There's a major heat transfer loss due to the much lower thermal conductivity of the film, as I talked about. And then you have a pressure drop increase. Whether it's organic dust or biofilms from microorganisms, that's all going to increase the pressure drop and restrict the airflow through your system. What you see here is as the biofilms are growing inside the coil, the actual phase velocity of your air is increasing. The picture on the top is showing, say, your air is coming in at 500 feet per minute with the surface area available inside. Okay, say it's 850 feet per minute for a clean coil. But when the coil gets clogged, the surface area, now these fins are getting coated, so your available surface area is less. So your phase velocity is now increasing, which is now not allowing the air to have a healthy heat transfer and resulting in much poorer efficiency. So the heat transfer efficiency of the cooling coil, the chiller condenser, and the cooling tower all play an important role in the system efficiency of the air handling system. The fan has to work harder due to the higher pressure drop. More chilled water has to be pumped, that too at a lower temperature. All of this resulting in higher energy consumption. And you should not ignore the impact on the air quality. Of course, the importance of improved air quality and associated health benefits are very important. You must have heard of the term dirty sock syndrome or sick building syndrome. That was a term in the past, which has been attributed to foul coils. There are several studies which actually show that when you improve your indoor air quality through a healthier coil, there is a reduction in employee absenteeism, and it also boosts productivity. And there are a couple of studies which are being funded by ASHRAE which talk about that. So when you look at coil cleaning solutions today, it's a handful. Scrubbing is not used so much, but chemical washing using biocides and steam washing are pretty common. Chemical cleaning may only remove surface growth while leaving material still embedded in the center of the fin pack. Some reports actually indicate that the high pressure steam cleaning can actually force the surface deeper into the fin pack, compressing the growth material so tightly that the only solution will have to be a new coil. Both methods, chemical and steam, can be detrimental to today's heat transfer issues. So coil cleaning is certainly necessary, but cannot be done economically with the frequency and the level that will keep the coil operating at a design level. So today, most of the times, people are just cleaning it, say, maybe twice a year or maybe a little bit more. The problem is that these biofilms are very stubborn. I mean, you just need one CFU or just a few colony counts to remain. And then when the cleaning is over and they get back into that environment, they start going back rapidly again. So it kind of defeats the purpose, and your energy impact starts getting affected right after that cleaning. So the advantage of UV is that UV is applied 24/7. So it's gradually eroding it and maintaining your coil to be clean throughout its time. And it's basically going to help sustain and maintain the coil to its design conditions and design performance. So at this point, we would like to get to another poll. And we want to see for you, which is the most benefit for UVC for coil cleaning? Which are the things which are important? Is it reduce labor costs from the chemical cleaning, improve energy efficiency, having a greener option, having environmental sustainability? You don't need to use chemicals. You got to reduce you got to turn the AHU off to clean this coil, so there's a downtime involved, and of course the indoor air quality is an important one. So which one of these or all of these are important to you? So Dave, can I hand this back to you?
Yes, Ashish, thanks. I'll launch this here in a minute. If we think about the first poll, as you're looking at how to answer this, we had a range from those who are not currently using it to those that are specifying, those that like to learn more about it. So depending on where you're at, really think of the things that are most important to you if you're not currently using it and you're considering it, or if you are using it, what do you see as the most important benefits? So we're going to go ahead and launch that right now. We'll take a few minutes, about 10, 15 seconds. And we will share the results once we do that. Okay, well, it looks like we have a broad range of answers here. So I'm going to close out and share the results. It'll be very interesting to see what the most important is. I think a key takeaway here is you can see it ranges across all of the benefits that UVC can provide. Looks like improved indoor air quality was at the top of the list. And that's certainly something that affects all of us in our everyday life. But cost, downtime, efficiency, all the things that UVC can provide were important to everybody. So appreciate your inputs there, and I'm going to turn it back over to Ashish.
Thank you. So let's dig in and look at how UV is applied to coils. It's just a picture of how a UV system is installed in front of a coil. It can be used in all kinds of systems. You can size it depending on what your air handler size or limitations is. We've seen staggered coils. We've seen coils ranging from 6 inches deep all the way to 12 inches and even deeper coils. So the UV system can be installed either upstream or downstream. We prefer that the UV lights are installed downstream of the coil because typically the drain pan is on that side, and it gives you a little bit more options. And the advantage is, of course, UV can penetrate through the fins of the coil, so it's not just on the surface. The coils are made of metal, and it's pretty reflective. I would say 60 to 70% reflective to UV, so you can actually penetrate the coil from there. So just a summary of the coil cleaning benefits. Of course, the healthy air, and it was good that IAQ is #1 on everyone's list. Of course, with improved heat transfer, you do get comfort because you're maintaining your temperature and humidity with the cleaner coil. I talked about energy savings. There's several studies which show that, okay, your energy savings are 15% and even more. Your maintenance cost goes down, your downtime is lower, and of course, it's a greener solution. So as we get in, I wanted to talk about some of the common questions which we fielded related to this topic over the years. How much dose do I need? What are the factors which affect how much dose is applied? How do I calculate dose? What are the main factors to implement properly? If I do coil cleaning, am I also getting airstream disinfection? How does that work? What are the current guidelines, standards related to coil cleaning? And then what is my ROI? So let's dig into some of these questions, not all of it, but I would like to get questions from you related to this topic. So let's talk about dose. The single requirement to size a UV system is to ensure that your UV system is delivering the right amount of dose to inactivate the microorganism of concern. Dose applied is a pretty simple calculation. Dose is the intensity delivered by your lamp or your lamp system multiplied by the exposure time. So to increase the dose, you can either increase your intensity or your lamps, number of lamps or output of your lamps, or you can reduce your exposure time. For a coil application, it's 24/7. So if you want to increase the dose, you can increase the intensity. But what's interesting is if you look at this calculation, suppose my intensity on the coil delivered by my system is say 50 microwatts. And if you think about how does that accumulate over time? So this is an example in 1 day, right? In 1 day, a 50 microwatt intensity is going to deliver a dose of more than 4 million microwatts and say a second per centimeter square. So the advantage of accumulative UV is great. So you don't really have to worry about which microorganism is there. There is a lot of dose which can be applied. Now, again, this is on the surface. So you got to keep in mind that you have fins and you have the depth of the coil. So what you have on the surface is not so much which is inside, but if you size it correctly on the front, then you can actually achieve the amount of dose you need to even penetrate and kill everything inside the coil. So talking about what is the susceptibility of the different microorganisms to UV technology. On the right-hand side, you see some dose values. You can see dose values. So the first one on the top is the Bacillus anthracis spore, 8,000. You look at E. coli, 6,000, Legionella, 12,000. When you look at virus, you have 8,000, influenza is 4,000, and in fact, when SARS-CoV-2 came out, I don't have it on this, but it's about 3,700 or 3,000 something. So SARS-CoV-2 actually is very susceptible to UV and gets inactivated very quickly. On the other hand, mold is thick-skinned and it needs a much higher amount of dose, at least 5 to 10 times the amount of dose for a bacteria and virus. So the susceptibility of these microorganisms is affected by several things. Your wavelength doesn't affect, okay? We can get into a little bit of detail one-on-one or later, but if you know about UV, all the microorganisms are very susceptible to UVC wavelengths, which is in the 200 to 280 nanometers. So it's important that your wavelength is correct. The amount of intensity, again, depends on the microorganism. The media type, whether the microorganism is on a surface, on a water, or in the air, is different. In air, the microorganism is more susceptible to UV, whereas on a surface in water, it needs a much higher dose. So when we get into a little bit more parameters in addition to all of that, there are other factors which affect your applied dose and intensity. The lamp power, what is your lamp system configuration of your UV? The wind chill factor is actually one of the very important factors. The airflow rate and the temperature has a bearing on how good your lamps are performing or what is the intensity. The graph at the bottom is actually showing on the y-axis is your intensity, on the x-axis is your velocity. You can see that there's an impact of temperature and airflow on the performance of the lamp. Reflectivity is important. If you have a reflective surface, then you're going to have UV light bouncing off, and you're actually getting more than what just the lamps are delivering. And of course, lamp life is important. These are typical low pressure mercury lamps which are used, and they do degrade a little bit over time. So you have to make sure that when whoever's designing your system is designing it considering all of that. So what are the key factors for successful application? Of course, coil disinfection. You have enough time. These lamps are on 24/7. You don't need a very high intensity. But when you look at an airstream application where you have air moving in a duct at 500 feet per minute, in a zone you have only like 0.25 seconds of contact time to kill your virus or microorganism as it going past the UV system. So these are two different applications. So a coil application is not really suitable for an airstream. You're not going to get that much. The lamp types are, of course, important. Standard output, high output lamps are used. And then, given all the factors I just talked about, I think parameter modeling is so important. a correctly designed UV system is very important. What's happened is that during the pandemic, there are a lot of people who basically said, hey, just stick a lamp in and you're good. You're going to get coil and you can get airstream disinfection too. But what really needs to be considered is all the different factors which I talked about for lamp output, your lamp spacing, and even your coil geometry, how big your coil is, all that goes into your application. So looking at an example here, the table at the bottom is showing if you have a system designed for a coil, and say you've targeted 100 microwatts, which is the standard guideline by ASHRAE, say 50 to 100 microwatts is what's recommended for a coil intensity. So suppose you have 100 microwatts for intensity. So what is that dose applied when you have air flowing at 500 feet per minute? That's really 0.25 seconds. The dose is just around 24 milliwatts. And if you're in a duct, your duct speeds could be even higher. They could be maybe 1,000 feet per minute, so the dose is less. The dose required for airstream disinfection is 1,500. So you can see that a coil application, when you have the intensity or your UV system designed for a coil, is way underpowered to get a reasonable amount of air disinfection. Even if you increase your coil from 100 to 1250, you're still falling short of what you need for air disinfection. So, and we'll get into that in our next webinar, where we get into the weeds on air disinfection and how UV is applied correctly for disinfection. So key factors for successful implementation is, of course, you need to look at your design has to be correct, it has to be validated. So anyone who's doing some modeling, you should ask that question, okay, how's that model, have you validated it? Does it work? Can you give some backup or certification for that? And then the functional design, easy to install and operate. And of course, that product has to meet all the regulatory, electrical regulatory and safety limits, whatever UL standards are there related to that, and UV exposure. We need to talk about UV safety. UV light can be harmful to human skin and eyes. So it's always recommended to be used in unoccupied settings. So inside the air handler, of course, it's inside you don't have people inside the air handler. And for the facility people who are going in and out of that, in that coil cleaning section, you got to have these door interlock switches so that the lights can be turned off when someone is getting in that area. So you have to make sure that you have your adequate safety measures, interlock switches. You want to make sure that you have a viewport. You can see that your lights are working. You want to make sure that there are no leakages in your system. And if you are going in with lamps on, maybe in an adjacent section, you want to make sure you're wearing your PPE. Mostly, you need to protect your eyes most. The other thing which we get asked is your material compatibility. There's so many things inside the air handling unit next to the coil. You have gaskets, you have wiring and all these materials. Sometimes you have a filter downstream or upstream of the coil next to the light. What is that compatibility of those materials to UV? So you need to ask a manufacturer on that kind of information. So what are the ASHRAE guidelines? The ASHRAE guideline, this is an excerpt from the handbook chapter. This is chapter 62 in the systems and equipment chapter, where the recommendation is to have a minimum intensity of 50 to 100. What we recommend is you need that minimum, but anywhere on the coil surface, you should have an average intensity of 200 microwatts. Recognizing that you have fins and then you have some reflection through the fins, and of course, as you go through the depth of the fin, your intensity is going to drop off. So you want to make sure that you have enough intensity. But it's a 24/7 application, so you have time on your side. So it's There are a couple of other ASHRAE chapters which I want to mention. Chapter 17 is on germicidal ultraviolet lamp systems. And then there is a test method for testing, checking your UV system for coil cleaning for surfaces, and that's ASHRAE standard 185.2. So UV has been recommended by of course, ASHRAE has been recommending it for a long time, but GSA spec has been there for a long time. And there's a facility standard, PBS P1000. Chapter 5 talks about using UV for coil cleaning as important to improve your indoor air quality. You might have heard of the well building standard. There is a well building standard for microbe and mold control, which talks about how UV should be applied. The Green Building Council has a fact sheet which really came about during COVID, but now it's been adopted in other states as well. I know California Energy Commission has something like that, but so this is just a handful. CDC has recommendations for UV, but also for airstream disinfection. There are several studies which confirm the energy savings which can be brought about by using UV for coil cleaning. The big one is the ASHRAE Research Project 1738, which was done by Dr. Banfleth, who's a former president of ASHRAE, and he did a study, actual field application in his university at Penn State, and also in a location in Tampa, and then he again collaborated with someone in Singapore, and they basically verified the energy efficiency savings from applying UV. And the one at the bottom is talking about how these UV systems improved the workers' health and well-being, reducing absenteeism and increasing productivity. So this was a double-blind crossover trial. So there's ample evidence, and we can send all these literature to you if you need those references. Again, most studies, I can only pack so much, but there are several studies I just wanted to highlight there. If you just Google and look at coil cleaning, actually in the ASHRAE handbook, we have all these references there, so you can actually look up all the references in the ASHRAE handbook. So there's enough evidence for coil cleaning, for energy savings, and then of course related to air quality. People have actually gone and measured, looked at the vegetative bacteria growing on it. They've done colony counts before and after UV and showed the advantage of using UV in reducing that growth on the coil. So, of course, indoor air quality improvement is number one. But if you have to justify from an energy standpoint, how do you justify a return on investment for a coil cleaning? So there are some calculators out there. It's fairly straightforward, and we can help you with that. You can calculate it. You can calculate the expected payback time in terms of energy savings compared to your total investment of UV, which would be just lamp fixtures and your cost, and then compare it to your ongoing maintenance cost and the energy savings. The annual savings have actually three components. One is from your cooling energy, and the second one is from your annual pressure drop, and the third one is your maintenance savings. So there are three components which will affect your annual savings. So if you don't have the data and a coil is really dirty, you can go in and measure your dry bulb temperature, wet bulb temperature, and actually go and measure your pressure drop. And we recommend that for any retrofit system because you really need to understand how badly your coil is. And then this data, along with your HVAC system CA rating, can be used to estimate the expected loss in coil heat transfer performance over the lifetime of the equipment. So just to recap, UV is tried and tested technology. It prevents transmission on surfaces, air and water, and that's where it's used all the time. We're focusing on coil cleaning. If it's applied correctly, it can improve your energy savings, reduce your chemical-based cleaning, lower your labor cost, and improve IQ. And of course, there's enough documented evidence and guidelines which help to convince this audience and your customers on the efficacy of UVC coil cleaning. So with that, I think this is what I have for a presentation. I want to give enough time for everyone to ask their questions, and I'm going to hand it over back to Dave at this point.
Ashish, thank you. Wow, lots of great information there. And throughout your time talking, a lot of questions have come in, really good questions. Appreciate everybody taking the time to type these in. We're going to do everything we can to get through all of them. If we don't get everything answered, we will follow up after the presentation. We have our regional sales managers on with us today, as well as our inside sales support team, and we'll make sure that your questions do get answered if we're not able to cover them in the time that we have today. So Ashish, what I'm going to do is read off the questions, and then I'll look for you to help answer them. First one we have is, does the copper surface of a copper fin copper tube coil inhibit biofilm formation or growth on the coil?
That's a good question. There's a lot of information coming out about antimicrobial copper-based coatings. So copper by itself, I would say, is not so antimicrobial. I guess it depends. It does, of course, copper and silver are considered antimicrobial, but there are some specific antimicrobial coatings, copper-based coatings, which could be added to enhance. But yeah, copper can inhibit, but when you talk about the load of these microorganisms growing, it's not going to really protect it so much. And there's enough evidence saying that even if you have these copper-based coils, there's enough growth happening on the surface and inside.
Thanks, John, for that question. Next one is, you had mentioned about steam cleaning possibly causing or exacerbating the coil fouling. Is there a study that you're familiar with on that, or we might be able to get some information on out?
Yeah. Yep, there is, and I'll send that over to, if you can just get that name, and we'll send that.
Okay, great. Next question. This comes in from John. Given air resistance time in the light field is about 1/4 second, is UV effective against airborne bacteria and viruses?
Yes, it's all about sizing. That's why I'm saying it's sizing, and a parameter modeling is so important. So UV has been used for air disinfection, of course, for a number of years, and it's all about how much dose you're applying. There's an ASHRAE guideline for air disinfection. This topic is on coil, but for air disinfection, ASHRAE recommends you need about 1500 microwatts, a minimum dose of 1500 microwatts. So then it's all about how many lamps you can pack in that space. And of course, you have to make sure what is your airflow speed. If it's in the central air handling system, your speeds are around 400, 500 feet per minute. If it's in a duct, where your speeds could be 1000 feet per minute or even higher, then you would need a much bigger UV lamp system. So it's all about selecting the right lamp configuration, and you're going to have the lamp output which delivers that amount of dose. And we do this for a living, and it's tried and tested. We have data showing, we actually have third-party BSL-3 lab data for SARS-CoV-2, which we'll be happy to share. But yeah, it's there. It's been used for a long time. It's all about making sure that you have the right amount of dose applied in that for that 0.25 second exposure time.
Great, thanks, Ashish. Now that question has come up a couple of times in here, and they may have come in before we actually had a chance to get into the section on dosage, but it's definitely an important one that are on people's mind. Next question, assuming both install are possible, wouldn't a downstream install be less effective because of the impact of cool air on the UV output of the lamp? that is directly linked to the temperature of the lamp?
Yeah, that's a really good question. If you have the option, you could place it upstream, but we recommend the downstream more because of getting the drain pans, because I mean drain pan is a breeding ground as well, and you get more bang for your buck by installing it downstream from an indoor air quality standpoint. Just looking at energy savings, yeah, I would agree with you that upstream makes sense. And in fact, what we've also recommended in the past is sometimes the coils are staggered, and you have to see how do you install them. Some people install some downstream and some install upstream. And if the coil is really, say it's really thick, 12 to 18 inches, we've had installations where if the coils are really dirty, we had to install them front and back. Sorry, upstream and downstream. Dave, you have any other questions? To see if Dave went on mute or not. Dave, you have any more questions? Dave, you're muted.
Testing. Can you hear me?
Okay. Yeah, now we can.
Okay. Yeah, the audio dropped out earlier. I'm not sure why, but I think we're back on now. Everybody can hear me?
Yeah.
Okay. So next question is, what's the energy usage to run these UV systems? Comes in from Aaron.
Yeah, could you repeat that question?
What is the energy usage to run these UV systems?
Oh, again, it depends on how many lamps. If you're talking about coil disinfection and you're just targeting that 100 microwatts, so a typical lamp uses it's probably a half amp to a 1 amp. So the energy use is really small, and when you do a payback calculation, you would find that the impact of the energy consumption from a UV fixture is much lower, is very low and insignificant.
Thanks, Ashish. This one might have come in one of the sections when it says, are these doses in microwatts per centimeter squared? It's probably
Correct.
the chart when you were, yeah.
Yeah, the chart I had shown was those doses were a 99%, I would say, inactivation for those microorganisms in microwatts, yeah, second per centimeter square.
Next one comes in from Aaron. Are there contaminants, organic or otherwise, that UV cannot eliminate?
So on that hierarchy, the beauty about UV is, and it goes back to 1900 when someone got a Nobel Prize showing that UV is absorbed by all DNA and RNA of microorganisms. So basically, UV is absorbed. The UVC, especially around 254 nanometer wavelength, that's what our lamps are producing, are absorbed by the DNA and RNA of the microorganism. So all of them are susceptible. So it's a question of how much dose you're applying, and is one more susceptible than the other, like I showed you that hierarchy. So there are single strand viruses, double strand, and on that scale, I said mold and fungi are much thicker microorganisms. UV does not penetrate so much, so they are more difficult to kill. And we're talking about microorganisms, not bugs or bed bugs, or not macroorganisms. When you look at in a building environment, you don't really come across prions. Prions are not really affected by UV. But in our HVAC world, except really high amounts of fungus or yeast, which they are the most difficult to kill. Everything else is susceptible to UV. It's all about how much exposure time you're giving it. So, and the beauty of coil application is if your lamps are on 24/7, you can accumulate that dose pretty fast. And over a period of time, you can pretty much get anything.
Okay, thanks, Ashish. Here's a question with some newer technology. Are LED UV emitters available at the UVC wavelength? This is coming in from John.
Yes, LEDs have been we've been watching it for 10 years. It's only in the last 2-3 years where they've started getting down to the wavelengths which are germicidal. I would say you could probably get an LED which is 265 nanometers. Even there are some companies which are even saying 254 nanometers, which is the same spectral output of a low pressure mercury lamp. So the LED lights are there, but you have to recognize that when you compare the efficiency of a lamp with an LED lamp is only 5 to 7% efficient compared to a 35% efficiency of a lamp. So if I have a 100-watt lamp output, 35% of that lamp output is UVC. For an LED, out of a 100-watt LED, only 5 is actual what's in use. So not so efficient, they're costly, and LEDs you have to really pack them tightly, and because the beam is much narrower than a lamp, you would need more rows of LEDs to compensate or to compare with the low pressure mercury lamp. So they're coming. Hopefully there'll be more advancements. The efficiencies are going to go up. The cost is going to go down to make it applicable. So there are some applications where people don't want to use mercury, and that's where the LEDs could have a good application. And also I want to mention that sometimes we've seen where we don't have the space in front of a coil to install a lamp. So that's where the LEDs can be used as well.
Thanks, Ashish. Next question we have. I design UV to turn off when the AC is off. What are your thoughts on this? The UV may cycle a dozen times a day.
Yeah, we've heard of people doing that, because especially during COVID, because the occupancy in the building was less and people were just saying, hey, why should I run my HVAC system? So yeah, there are positives and negatives. The negatives are, of course, you turn it off, you're going to start having these microorganisms and biofilms grow up again. So you're kind of back to the drawing board, and you have to again realize that energy savings and air quality. The problem is these biofilms and microorganisms just keep growing whether your system is on or off.
Ashish, on that one, any thoughts on how many cycles per day or the time that it might be off? I know there's cases where they do want to go in an on-off cycle.
Yeah, and I understand a lot of people are just turning the system off based on occupancy. I don't have a number for you, but because like I said, the advantage for coil cleaning is of course 24/7 application, and it's cumulative. Once you maintain your coil, then you can maintain it if you leave it on, or even if you turn it off for a short duration, it's going to be okay.
Okay. We do have a number of questions about turning it on and off, so we'll get some more detail out to our regional sales team on that.
Yeah.
Okay, here's a question coming in from Eric. How frequently does a UVC bulb need to be replaced to maintain effectiveness?
So it's all about the design. Just like any lamp, any fluorescent lamp, you have an electrode, and over a period of time, that lamp is going to degrade. So any lamp has about a, say, 10 to 15%. Any good lamp would degrade about 10 to 15% in intensity after 1 year. So if your system is designed correctly and they've allowed for that 15% reduction in 1 year, then I would say, and a standard recommendation is replace your lamp after 1 year. But you can oversize your system so that your lamp can run longer. The lamps don't go bad, they just reduce the output. So if you want to run your lamp for 2 years, you just design your system accordingly that you're going to get more output over 2 years life. You have to keep in mind that, okay, if you're just adding more lamps, you're also adding a little bit of extra energy because of the consumption by the lamp, even though it's light, but it does increase. So we recommend 1 year change out. That's how we size it. It has to be optimally designed, but yeah, it can be sized for a 2 year application, for a 2 year replacement cycle too.
Okay, next question coming in from Keith. Are you seeing any advancements in UVC to be UL 2998, no ozone emitting capabilities? If not, what do you recommend and what types of environmental sensing technology do you recommend to monitor this with the various UVC devices that are currently installed or will be installed? Great
really
question
good
on
question.
ozone.
Yeah, it's a great question. Most of the industry today for coil cleaning is using low pressure mercury lamps, which have an output of around 254 nanometers. And these lamps don't produce ozone. There are specific lamps which have a combination of 185 nanometer, which is ozone producing, and 254. But those are designed for producing ozone. So the lamps which we use, most of the industry which uses low pressure mercury lamps, they do not produce ozone. Ozone is generally formed beyond 235, 240 nanometers or and lower. So since our lamps are 254, there's no ozone. Anything lower than 240 produces ozone. So there's a new technology which has come out called far UV technology, which has an output of 220 nanometers. So, and that has been shown to produce ozone. So the UL 2998 applies to that. Would apply to that lamp. You have to make sure that any system which you have, which is using lamps below 240 nanometers, should be tested to UL 2998 for ozone. But 254, not a concern. They don't produce ozone.
Yeah, Ashish, I think we have time for one more question. I was not able to get to everybody's questions, but we have these captured, and we'll be getting back out to answer anything that's still open. Question would be, does the heat generated from the UV system cause a loss of heat transfer, or does it need to be derated?
No, the heat generated by UV system is minuscule, especially for a coil cleaning. If you're thinking about an air disinfection where you have a huge bank of lamps and much more lamps and high output lamps, then you would think about it. But those are typically not installed right at the coil. But there is some impact, but it's insignificant compared to the energy savings which you realize from your cooling transfer.
Okay, well, Ashish, thanks for the presentation, the answering of the questions. And most of all, I want to thank everybody quickly again for taking the time to attend the webinar. We're going to have to close out here in a minute, but before we do, I just wanted to let you know of our next webinar that's coming up. It's June 19th, as you see on the screen here in green, and there we're going to dive into air disinfection, including some information on ASHRAE 241. So, today's topic on coil cleaning, there were a number of questions that came up about the level of UV and what those disinfection rates were depending on the airflow. So this is an important factor when we get into airstream disinfection, and that'll be where we'll dig in. As you register for that, please send in your questions. We'll have the same format as we did today. So as we wrap it up, I again want to thank everybody for attending and have a great rest of the day, evening, or afternoon. Thanks, everyone.